I was searching on SnapEDA and found out this one is showing 9 paths over here and it's justified to the left. So very likely this is going to work. So what I'm going to do is I will download it. I can see I already downloaded and I put it into here. See, this is a library. You can see it should be in your documents, Eagle libraries. You can directly just copy and paste this library file in here. And then you want to keep things well organized. Okay, so what I'm going to do is I used, you see, all my different components libraries, but for this kind of memory, since I'm not expecting that I'm going to have millions, or not millions, but 20, 30 different types of memory chips in the future. So I'll just put in others for now. And I'll double click this library. You can see I have all the other components in here. So I will just load the device and import. So hopefully I can find it. And so if you close this library and reopen it, you can see this one shows up because it's just placed in the folder, but there isn't a green dot behind it. So you have to right click and use it. So the thing is, for now, you should be able to directly use it and modify it, but I would like to, just load it to others, because if you have so many different libraries in the future and you place all of them over here, it will be a total mess. So I will go here and do this import. Oh, let me see if I can directly see it somewhere. Device. Oh, it's not showing up here, right? So I'm going to import, and I will do this search. Okay, so it shows up, right? So I'm going to directly load this device into my library, and already has a footprint associated with it. By looking at the bottom of the pin layout here, and what you can tell is this one is not being used really. So when you insert SD card, it's starting from, if this is considered as the left side, so this is 1, 2, 3, 4, 5, 6, 7, 8. So total 8 pins. If you look at the SD card pinouts, it's actually 8 pins as well. You can see it's totally 8 pins. And when you insert it, like on the top, like this, you insert it. So this pin is aligned to the pin on the left. So that pin on the left is going to be this pin. So the number A here, this is A, 7 to 1. So A is not being used. You can see the green one here, the green pin names over here. So A is not being used. So this really matches whatever in here. So I'm just getting more confident that it's going to work. So this socket is going to work for our SD card. And then I was looking at the PCB board over here. I can see, because these are turning into blue color, which means they are being placed on the bottom of the board. So that's why it's blue color. And so remember, the card is inserted in here, right? So this side is considered as left. So this is number 8, because there are totally 8 pins in here. Okay, this is number 8. So number A, you can see it's not being used. Oh, I want to correct myself really quick. So this one has 9 pins. But this is totally not being used at all. This will connect to the pin 8 of the SD card, but the thing is, it's not being used. The reason I know that is, you see here, it's a cross, so it's not being used. So I said this is aligned to this pin. Actually, that was wrong. So it's actually aligned to this pin. So this pin is not even connected to anything. This one is connected to the SD card, but it's not being used. Hope that makes sense. And then you come back here. So the SD card number 8 pin is actually connected to this guy, but it's not being connected to anywhere else. It's not being used. And then I started looking at 7 to pin 1, and I was looking at the traces connecting to the port B, port something like B1, B4, and I was looking at the SPI connections. I was able to align them, right? So for example, B2 is SDI and B3 is SDO, and things like that. So I was able to align them and make a table here. So I was trying to compare this to whatever I saw over here. Okay, so see, pin A is not being used. This is from the pigboard PCB. Okay, by looking at the traces. So pin A is not being used. Okay, over here. And pin 7 is SDI. So you can see it's SDO over here, but it's SDI. It's SDI of the PIC. That makes sense because that's master in. Okay, and this is output. So it's DO from the SD card and it's D in for the PIC. And then VSS, which is ground. Okay, and then clock, SCK, which is also clock. And then VDD, 3.3 volts. And then DI, so DI for SD card, which is DO for the PIC. And then CS. And then this is not being used. So this is a perfect match. So then I think it's ready to get back to this guy. And by looking at it, I'm going to open up this as well. By looking at it, right? Since we know that this is pin, there are 9 pins, right? There are 9 pins. It's the same number of pins as the Amazon SD card, which makes sense because we do want 9 pins to solder them onto it. But the thing is, this is not being used. So this is number A is also not being used. Okay, it's soldered connect to the pin A of the SD card, but it's not being used. And this pin is not even connected to the SD card. Okay, just make just make sure you understand that. So it turns out that this is the pin 9. It's not connected to anywhere. It's soldered on the PCB, but not when you insert the card pin A starts from here. Okay, and then A7 6 5 4 3 2 1 like that. Now let's look at the symbol. So it becomes like 7, okay, starting from 7, which is, because you can see number 8, it doesn't even have a number 8 because it's not being, number 8 is over here. Doesn't matter, it's named like a data 1, but we can change the name in the symbol later, okay? So it's not being used. And this is number 7, which is SDI, and number 6 is ground, perfect. And number 5 is clock, perfect. And number 4 is VCC, perfect. And number 3 is SDO. It's named as CMD. We can change it later. And number 2 is CS. And number 2 here is like CD data 3. We can change it. And pin 1 is not being used. So we can change all the names to the correct ones that we want to use. All right. I'm not sure if we can change it here, so we cannot change it here. So I'm gonna go back to the library, or let's do the symbol directly. I'm gonna directly configure the symbol here and change the names to the correct ones. So I'm gonna open this up at the same time and makes this monitor smaller. Right, by looking at the names on the other side. So number 8, so starting from pin 8, this is not showing the pin number anymore. Let me see if there's a way that I can show it. It's not showing. So it's better to make a snapshot. So let's go back. So we're not using this anymore. Let's go back to, still have to go to devices and make a snapshot. Let's do that. Right. Okay, make a snapshot first. So I'm going to save this one to, so I'm not losing it. I'm going to make a snapshot over here. Okay, and then go back to the symbol so we can modify it. Okay, so first we want to start with, all right, let's do this. So for sure we don't need pin 9, right? But we do we have a pin 9 over there? We do. So it's basically from 1 to 9 for the layout. So pin 8 is nothing. So let's go to pin 8 and change it to, oh, over here. And let's change it to unused. Let's see what other people use name wise. Oh, NC, not connected. I think NC makes sense. Use NC for pin 8. And let's use, this is helpful to label it. Let's just label it. Pin 8. Okay? So this is pin A NC, and then pin 7 is going to be SDO. Pin 7 here. Let's call it SDO and pin 7. And next will be pin 6 is ground. VSS, we don't have to change it, but I prefer to give a pin number over there, so we are not having this issue anymore. Pin 6. And then I'll just drag this down here, probably it's more helpful. Pin 5 is clock. I'll just call it SCK. And pin 5. And VCC, pin 4. And SDO pin 3. Pin 3 is over here. And this is SDI. Pin 4. Right, since we already have SDO here. And then pin 2 is CS. Pin 2 is over here. This is CS. And pin 1 is not connected. Pin 1 is this guy. Let's call it NC. So now, oh, let's also add a pin number over there. So we have, these ones are unused. So this is pin 9. I don't think we need to do anything to it, just leave it there. Okay, it's not being used. Shield will just short the ground in our circuit. So I think that's it. So I'm gonna save this guy, save it, and I will go to the device and see if it's changing anything for the device. Come back here and make sure the connections are still right. Since I just changed the names, so I don't believe that it's gonna change any of the connections, right? So let's see. This is CD. We just leave it unconnected to anywhere else in our schematic, so we just leave it there, which is fine for pin 9. And for pin 2 is connected to pin 2, pin 1, pin 8, pin 5, pin 4 is shorted to pin 3. So that might be something you need to concern. But let's keep moving and see what's gonna happen. Now pin 7 to pin 7, shield doesn't, it's not connected to anything, but we can manually short it to ground. And pin 4, because you can see it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the shield are just these pins. If you short it to ground, they will, be able to short it to the ground, maybe pour the copper. Let's leave it there. So these doesn't really matter. So the things that matter is our pin 3. Why the pin 3 is shorted to pin 4 here? Because we made a mistake over here. So pin 4 is VCC, and pin 3 is SDI. So I name it incorrectly. I'm sorry for that. So let me have to go to symbols and change this one to pin 3 and save it. Okay, and then come back to the device and go to connect. It should be right for now. Okay. 21A53746. So that's perfect. I think it's ready to use now. So another thing is we need to go to here, go to the layout and measure it and compare it to the dimension here, just roughly, because there's no way that I can make it accurate. It's not providing the details like the DigiKey provided. But now let's see. It's about like 14, the size, which is length, width, and thickness. Let's care about this first. This is 14.5 by 14.8. So change this to millimeter first. So it's using the millimeter as a unit. It's like a 14.5 in dimension. So let's see if this is similar. Uh, 14.5. It's like going to 17. 14. So I think you should start measuring from the pads, I believe, or maybe from here. Let's see. 14.5 by 14.8. Okay, so it should be starting from here. Okay, 14.5. Okay, it's about right. 14.8 here, and this is 14.5. So I think this is accurate, and the pads, gaps between the pads should be standard, so we shouldn't worry about that for now. And I think after changing the names, this one should be ready to use. Okay, so I'm gonna go ahead and save it and place it into the schematic and upload it to my website so you can directly download and use it.